Welcome everyone, I'm Mike and this is finally Animatronics. In this video I'm going to walk through some of the refactoring I did on C++ code. I got relatively in-depth, it needed to be more flexible and follow some more best practices. So let's get to it. So let's talk a little bit about the code. If you saw my last video, you saw that I just basically had at the very top level some basic commands to cycle through and move a linear actuator. Really basic stuff, and it only works for this actuator, and it was all in one file. So I decided to refactor it, make it a little more flexible, and of course I went way down a rabbit hole. So I have all this code. I'm going to walk through it a little bit and describe sort of what I've done. All of this code is in GitHub. I will have a link to that repository. It's a public repository, and I'll have a link to that repository in the comments, in the description below. So when we enter the application, we come in through the main.cpp file. On the Arduino, it does two things. One is it calls setup, which initializes the system, and then it calls this loop, which, like it sounds, it loops over the code, and maybe it does, repeats tasks. In this case, the task that it repeats is listening on the serial port. But we want to talk about the setup first, and that can be represented here. The objects can be represented, at least visually, in this FA device objects diagram, and that's also in the code base in docs diagrams. And what you see is that I've basically abstracted out the concepts. So we have an abstract base controller and device classes, and then from there we can implement individual devices. In this case, we've only done one, the PWM linear actuator, and individual controllers. When we create those, you'll see we use a factory to create each of those. It's kind of a standard pattern. We also save an instance of those to a registry for each. So we have a device registry and we have a controller registry. So when it comes time to access those, they already exist and we can just reference them by name, get them out of the registry, make the connections that we need to make. Right. And you'll see that the device actually has a reference to the controller, which may seem a little bit non-intuitive as far as the direction, but the device provides a lot of information to the controller. The controller runs the command that controls the device. So it's a little bit of circular kind of a thing, but as far as in the objects themselves, you'll see that the device just references its controller. Controller can have multiple devices. Anyway, we'll talk more about that. The other object or class of objects over here that you see is actions. I don't really have that implemented. I do have a few classes out there, but I don't use them. The idea with an action is that we should ultimately be able to encapsulate some sort of set of commands that represent an action, like look left, look surprised, nod your head up and down, whatever. I don't know what that exactly is going to look like at this point, but you just know for now. There may be a few classes out there, but we don't use those yet. And right now we're just going straight to the controller and the device. So I have tried to capture the high level, sort of the flow, the system flow when the code is uploaded to the Arduino. The setup is automatically run, and then it goes into the loop. And this is what happens based, from my code. And the first thing that happens is the system loader loads from a JSON file the information about the devices that we have. And you can see there's this device config file in the code, and it defines our controllers right now, and then the devices inside the controllers, or what's controlled by each controller. And you can see I only have one controller right now, and that's that Adafruit PWM controller we were talking about earlier, and only one actuator. But ultimately, there'd be a lot more going on here. And so the code parses that information, and then it goes through the controller factory, which creates all the controller instance, the objects, And then for each of those controller factories, it also iterates through the devices and creates the instances of those devices, and it puts both in their respective registries. At the same time, this doesn't really say that, but at the same time, the device itself that gets created has a pointer back to its respective controller. So that's basically all that happens. There's a lot of parsing and validation, some validation going on under the hood, but at the high level, you can kind of follow through this. And then after that, we go into this loop in main, and that is basically just calling a listener, which has a lot under the hood, as you can see. Calls a listener, which pulls the serial port, handles any incoming bytes, and then marshals those bytes into a message based on like a new line. And so then once it has the bytes all marshaled into a message, it processes those messages. And then from our side, we have this command parser, which takes the message and parses it into something a little more understandable, a command object that we can pass around and has all the information we need for a command. And then once that's parsed, we have a command executor, which we just call execute, and that executes commands. And so inside that command executor, it separates out it's a list of commands, and so it separates out into individual commands, and it executes each individual command. In our case, it would go to a device. The command would reference what device it should go to, pull that device out of the registry. In this case, it could be any device. We only have one, which is a linear actuator. Calls execute on that, which says, hey, here you are, I need you to do these things. Also sending in the command so that, we know it can move, but we want it to move a certain amount or a certain percent or whatever we need it to do. And that command object has all that information. Then that goes back out to the controller, or it contacts the controller and does an execute on the controller. We go to the device first because there's information we have to understand about the device that we send to the controller. And then the controller says, this device is on channel so-and-so. I want it to do, a movement, a certain amount, number of microseconds ticks, or whatever it is, and whatever the low-level sort of command is. And then the controller does that. Now it ends up, physically affecting the actuator, but through the code we start with the device, and then we move to the controller. And then in this case, this is just one example of what the controller can do, is write microseconds, and so that's what we do when we've converted sort of the percentage we want it to move into this microseconds format. So we say write microseconds, and then at the very lowest level, we talk to the driver and we say, hey, send the instructions to the driver. Now, I don't have all the parameters. There's a lot getting sent around here. That's a lot you can take a look at. But, if you look at this, Adafruit PWM controller, for instance, you see that, when we execute, it's actually sending a command. And that command is what's controlling what ultimately gets sent to write microseconds, which in this case is a channel and a pulse, right? So there's a lot getting passed around, but that should give you basically a high level idea of what the flow is, so that when if you decide to download this code and take a look, or just look at it in GitHub, you can start to sort of understand, what the paths are and what the objects are that are controlling the movements. So I have talked a little bit about the fact that we go into this loop and it creates a serial listener. That's different from sort of what I did in the proof of concept in the beginning, because that just physically looped through some commands, just hard-coded commands to the controller, just to make sure that we can make sure the, I actually had everything right so the actuator would move. But now we're listening on a port, and a serial port. And so what I'm doing is I've created this Python script that basically goes out, I run it, I name a file, it goes out and grabs that file and submits it to the serial port, the USB port that the Arduino is running on. So that it's pretty simple code. I do run it with poetry. For me, if you're not familiar with poetry, it'd be a good thing to maybe look into if you're interested in Python. It just kind of manages your environment, and it's convenient once you get the hang of it. So because you'll see that I have these instructions, and they're really basic, but this is how to run the command, and you'll see that there is a device here, and it gives you some instructions on how to find that device. All right, let's run down the directories real fast and just like what some of the objects are. Like I said, this is available so you can take a look at it. This isn't really a course on C++. If somebody wants, enough of you want more of a explanation on the C++ itself, I definitely do something like that. So, the first is the config, the configuration. Action config is, I don't use it yet, so whatever's in there is kind of, I wouldn't pay too much attention to it. As I said earlier, here's the device config, kind of the idea of all of the parameters that go along with the devices. And then probably jump down to loaders, because that's what happens first. Again, actions I wouldn't worry about, but the device loaders, the system loaders, I think I only use one of those, and that's what we use to load up the system when the Arduino first starts, when the code is first uploaded. And then from there we utilize, you'll see that I have factories and devices. So factories, this is what we use to create these individual objects. It's kind of a common pattern. And then registries is where we store them, and you can just see that a registry is just a map basically of strings, string name, and then a pointer to the actual object that we're storing. So pretty straightforward. And then we have our execution, right? We talked about the command executor, and I think our comms is probably a better place to start. So this is the code. If you dig through it, this is the code that actually listens on the port, intercepts a message, processes that message, and so it parses that message out through this command parser, and then executes it through this command executor. So there's not a whole lot going on, but I have tried to break some things out and abstract them out, so the controllers have an abstract controller, and then the individual controllers can inherit from that. The devices the same way, and so I have tried to do that. And I think the only other thing really of interest is the commands. You see, I talked about the command parser already, which parses out the commands, but this command object is very important, because this is what gets passed around with the sort of the pieces necessary for that individual command. So the JSON that comes in is parsed, and it winds up going into this command object, and that's what's passed around and has the information about the one specific command that you're running at that time. All right, so let's look at what happens when we actually run we upload and run the code on the Arduino. So first of all, we go down to this platform IO, which is what we use to manage our builds. And this is a terminal down here below. And so first thing we do is build the code. So this builds the C++ code. You see success there. And then we upload the code to the Arduino. When we upload this code, we see, when we upload this code, it immediately starts running on the Arduino, which means that this main setup code is getting run. So you could have errors right off if something in your setup is broken or your configuration isn't quite right. So yeah, this is now on the Arduino. It's been run. So now if I go over here and I run this JSON program, which does this one, pulls this one file which has commands to just do a quick little movement, 3 little movements, or a movement stop and another movement, and I run that, All right, next I want to set up a monitor, and so what this does is the output from the code won't automatically show up here in the terminal. But if I go to this monitor and just set that up, now that any output from, any print lines or anything, or errors or anything like that from the actual code on the Arduino will show up here. So if I go over here and I run the poetry command to submit a simple command file to the serial port, there's a lot of debug information I've put in here. So there's a lot of command, and a lot of output coming. But basically, yeah, we see this Arduino moving the way we want it to, right? And that's pretty much all there is to it. And it's just a simple, until we sort of create some more sophisticated input files, JSON files, that's kind of what it looks like. All right, so let's look at what happens when we actually we upload and run the code on the Arduino. So first of all, we go down to this platform IO, which is what we use to manage our builds. And this is a terminal down here below. And so first thing we do is build the code. So this builds the C++ code. You see success there. And then we upload the code to the Arduino. When we upload this code, it immediately starts running on the Arduino, which means that this main setup code is getting run. So you could have errors right off if something in your setup is broken or your configuration isn't quite right. So yeah, this is now on the Arduino. It's been run. So now if I go over here and I run this JSON program, which does this one, pulls this one file which has commands to just do a quick little movement, 3 little movements, or a movement stop and another movement, and I run that, how amazing is that? It does what it did before with a lot more code. Anyway, I think that's enough for this video. I don't want them to get too long, and this is a lot of coding review. I do have some other stuff I want to show. I did try to hook it up to the, to the actual skeleton head. Didn't really work all that great. And I also want to kind of go over that Python code that I kind of alluded to but didn't really dig into. So we'll do that in a future video, but for now, thanks for watching, and hope to see you again.